Last time we looked at a couple examples finding area underneath a curve just by counting. I'm going to get a little more sophisticated this time, but not too terribly sophisticated. It's still going to be pretty easy to deal with these. Here, y equals 5 over the interval 0 to 6. You know that y equals a constant. Just gives you a horizontal line at 5. And we want the interval from 0 to 6. And we want the area contained below that curve over that interval. And you probably recognize that shape as being a rectangle. The length of 6 is the length of the interval, and 5 is the height of the function. So of course the area here is going to be 30. Length times width, or base times height, just like you always do. Here's one that's a little more challenging. We have y equals 8 minus 2x. That's going to be a line with a y-intercept of 8 and a slope of negative 2. So it's going to decrease, and it's going to hit the x-axis at 4. Now, unlike the previous one we had an artificially imposed beginning and end here. This one sort of has naturally imposed beginning and end from 0 to 4. So we know we're talking about this area under the curve here. And you know it's a triangle. You know the height is 8. You know the base is 4. So 1/2 times base times height is going to give us 60. Nothing surprising there. We could have found that by counting squares also. It looks like there's about 16 squares in there. 4 plus x from 1 to 6. So look at 4 plus x. That's going to have a y-intercept of 4 and a slope of 1. So it's going to be increasing like such. We're looking from 1 to 6. And that's going to give us a trapezoid. We have this side here is 5. This side here would be 4 plus 6 would be 10. And our base is 5 from 1 to 6. And if you remember the area formula for a trapezoid, it is 1/2 base 1 plus base 2. So 5 plus 10 times the base. Actually, they call this the height. This would be base 1, this would be base 2, and the perpendicular distance between them would be the height. So there we get, what, 1/2, 5 plus 10 is 7.5 times 5 is, I don't know, 37.5 maybe. I seriously don't know if that's right or not. I apologize if it's not. Another way you could go here is just to break this into two separate pieces, right? Dividing something into pieces that we understand is a really good way to go. That gives us a 5 by 5 square there. That would be 25. And this is 5 by 5, but it's a triangle, so 1/2 base times height, that would be half of 25. That would be 12.5, and that would give us our 37.5. So I did do that in my head, and I did do it correctly. Another shape we might run into, if you know what the graph of this is, you're good to go. If you don't, you can pop it in the calculator and graph it, and you'll see that it is the top half of a circle centered at the origin with a radius of 5. So we're looking at the area of this, and you know the formula for the area of a circle, right? The radius is 5, and our area is going to be pi r squared, so pi times 25, but then it's only half a circle, so half of that, so 12.5 times pi. And one more real quick. 4 minus x is going to start at 4 and decrease. And we're going from 0 to 6. So we have the same situation as we did in the previous little video. We've got some area that would be considered positive, and that's going to be 4 times 4 is 16. Half of that is 8. And then this is going to be an area of 2 down here, but it's going to be negative. So we would call that area 6. That's it. See you again soon.